Let's learn about geometric proofs. Theorem: a cat has 9 lives. Proof: no cat has 8 tails. A cat has 1 tail more than no cat. Therefore, a cat has 9 tails. On our agenda today, we're going to complete a table of properties as notes, and then in class, we'll start geometric proofs. So let's get ready. You're going to have a note sheet that goes with this, so you're going to just be more taking notes today, and you will be able to use this as a reference sheet on your quizzes and tests, so it's really important that you fill this out. These should be a review. We just want to get them all in one place. So you're going to need paper, if you want extra, pencil, and your note sheet to get started. So the first one we want to do is segment addition postulate, and we know that we can abbreviate this SAP because we're going to use it a lot. It says 2 smaller segments add to the largest segment. The picture that would go with this looks like this. If we have segment AC with a point B somewhere in there, then I am allowed to say AB plus BC equals the entire segment AC. Doesn't equal a number. We'll fill letters and variables and numbers in later, but that's what the segment addition postulate says, is the 2 little pieces equal the big piece. Angle addition postulate is the same idea. We can abbreviate this one AAP. It says 2 smaller angles add to the largest angle. So if I draw a picture, I might have something like this. We'll add some letters on. A, B, C, and D. I'm going to throw some numbers in there just to make it a little quicker for writing. So my 2 smaller angles are 1 and 2. My big angle is ABC. So we can say the measure of angle 1 plus the measure of angle 2 is going to equal the entire angle that it makes up, the measure of angle ABC. Definition of midpoint. So a midpoint is exactly in the middle. It's between, but it's exactly. So if we have a segment A, I'm going to do M for midpoint, B, we know that it's going to make 2 congruent segments, so I can add congruent marks, and from that conclusion I can say AM is congruent to BM. Definition of a segment bisector. So a little bigger than a midpoint, but it still is going to break a segment exactly in half and make 2 congruent segments. So this picture, if I had segment A, B, and now either I have a segment or a line or a midpoint, that is the segment bisector. It's going to cut it in half. We'll say that it cuts it at its midpoint M. It's going to create 2 congruent segments, AM congruent to BM. Definition of an angle bisector. That's going to cut the angle exactly in half and make 2 congruent angles. So if I have this picture and I have a ray coming out exactly in the middle, and I'm going to call this angle 1 and angle 2. Let's say that this is ray BD. Ray BD is the angle bisector. Then I know that I can put congruent marks on there, and I can say the measure of angle 1 is equal to the measure of angle 2. Angle bisector cuts it exactly in half. The vertical angle theorem. We have another abbreviation for this because we're going to use it a lot, VAT, and it says the vertical angles are congruent. So this is our picture of 2 intersecting lines, and however they intersect, they're going to create this X. And if I put in angle 1 and angle 2, those are vertical angles. They're across from the vertex. Those are going to be congruent. So angle 1 is congruent to angle 2, vertical angle theorem. Definition of complementary angles. You knew that coming in. Complementary goes with 90. So it means 2 angles that add to 90 degrees. Our picture might look something like that. If I know it's 90 degrees, then I can put the right angle box in. I'm going to call this angle 3 and angle 4. So I could say the measure of angle 3 plus the measure of angle 4 equals 90 degrees. And the reason would be definition of complementary angles. It would not be angle addition postulate because angle addition postulate can't equal a number like 90. Definition of supplementary. Mistake. 2 angles that add to 180 degrees. So our picture is going to look like a straight line with a ray coming out of it. We'll call it angle 5 and 6, and we'll conclude the measure of angle 5 plus the measure of angle 6 equals 180 degrees. If I see that, I can say definition of supplementary angles. Linear pair postulate. Two angles that share a vertex on a line and add to 180. So back to 1 and 2. The definition of a linear pair says two angles that are on the same line. It's the postulate that says they're now going to be supplementary and add to 180. So measure of angle 1 plus the measure of angle 2 equals 180 degrees. Definition of perpendicular lines. The symbol for perpendicular is this upside down capital T, and if they're perpendicular lines, they're going to intersect at 90 degrees. So if I'm told that, I can draw a picture and put the box in there to represent that 90-degree angle. Definition of right angles. We know that right angles equal 90 degrees, so if somewhere in my picture I want to conclude that or I want to use it, I would say definition of right angle. The substitution property. If two things are equal, so like if A equals B, then they could be plugged in for each other. And then later on, I have 3 plus B equals 5. I could substitute A in and say that 3 plus A must equal 5 then. So substitution is any time you're plugging another thing in that was equivalent. The reflexive property. It equals itself. So for this one, we might have something like segment AB equals segment AB. We'll put congruent mark there. It just equals itself. The symmetric property, it changes the order and it's symmetrical, so it's the mirror image. Something like AB equals BA. Transitive property. You need 3 parts to make this conclusion. So if I had if angle A is congruent to angle B and angle B is congruent to angle C, notice how I have that angle B is the same. The middle piece is the same. Therefore, I could just kind of jump over it and conclude then angle A must be congruent to angle C. So those are your 3 parts with your middle piece being the same, so you can conclude that A equals C. And the definition of congruence, we're going to use this in proofs anytime we switch from an equal to a congruent sign or vice versa. If you see that in a proof, you're going to say definition of congruence. Nice job today.